All right, thank you, Father. Again, good to be back with you. You can see that I have provocatively called this particular presentation, Noah and the Flood, Surely They Must Be True. This is only the second time I gave this talk, and I had to remove 65 slides to get it down to the point where I could get it in less than an hour. So there's so much good stuff to talk about here, but I think you'll get the idea. So this is what happened to the dinosaurs. They simply missed the boat. And you can see here we had to change that word. Oh, shoot. Was that today? So we're going to have some fun exploring our world. This, of course, is not like biology where you can observe it and test it and that kind of thing. This is historical science, really, trying to look at the earth today and look back and say, well, how did this happen? Where did it all come from? I say Noah is different. What do I mean by that? Well, Adam and Eve and original sin are settled doctrines. To be a Catholic, you have to believe that, even though, of course, all my kids were told that it wasn't true. The age of the earth and the 7 24-hour days, as you has pointed out, they were always believed for, 1900 years, 1950 years, but you can question that, right? If you're a Catholic, you don't have to believe that. It's not a doctrine of the church. It's not connected directly to our salvation. But Noah is in between because Scripture and tradition clearly proclaim as historical fact that God destroyed the earth at the time of Noah, and all peoples alive today came from the 3 sons of Noah, right? So what do we make of this? It seems like it's something we should investigate further, rather than just give up, right? Because modern science says it's not true. We're not going to try to understand today Noah's building skills or supernatural intervention or how the animals got to the ark or how they found food or how they spread across the earth afterwards. There are books written about that, and you can read it and consider it yourself. But we do know this. We know that Christ believed that Noah was historical. He said the coming of the Son of Man will repeat what happened in Noah's time. This is in Matthew, the words of Christ himself. In the days before the flood, people were eating and drinking, marrying and being married right up to the day Noah entered the ark. They were totally unconcerned until the flood came and destroyed them. So will it be at the coming of the Son of Man. So those are pretty strong, very specific words that indicate that Christ believed in Noah. God made a covenant with Noah. It's a very important covenant that was passed down to us. Abraham descended directly from Noah. Christ's father Joseph is descended directly from Shem, Noah's son. In Hebrews, Noah is listed with 2 other patriarchs as historical and an example of great faith. And in 2 Peter, Owen mentioned this. Peter talks about scoffers. Where's the promise of his coming, at the end times? And the world that then was overflowed with water, perished. Very specific discussion of Noah and the ark in the New Testament, confirming what is talked about in the Old Testament. We also know that every ancient culture we look at, one reference says at least 270 flood stories have been found in different ancient cultures. You've probably heard of the Babylonians. Look at the Babylonians. Now, the green blocks mean that particular thing. These are pieces of the story out of Genesis. The green means that particular thing was found. Look at how close it is in the Babylonian. But Syria, Persia, Greece, Italy, China, India, the Cherokee Indians in the United States, when the missionaries came here, they found out that Cherokees believed in a Noah, an ark story. Over here you see destruction by water almost universally found. Humans being saved almost universally found. And universal destruction across the earth, not a local flood, but the whole earth almost universally discussed. Very interesting. Now, does doubt about evolution lead to questions about Noah's flood? Of course it does. And how about the age of the earth, right? Now remember, you could have a Noah's flood that's recent. It doesn't, because we prove Noah's flood, or we believe in Noah's flood, or we see the evidence for Noah's flood, doesn't necessarily mean we've proven that the earth is only 6,000 years old. So again, we can break it down again and say, okay, Noah's flood is separate from the age of the earth question, really. At the end of this presentation, I do have some age of the Earth kind of slides, but they're very short. I had to take most of them out. So this particular presentation is not necessarily an age of the Earth presentation. It's more of a Noah's flood presentation. But we know people like me doubt Darwin. Darwin doubters, they're called, right? And special creation, as I mentioned, is the only other alternative, and age is the foundation of evolution. And Lyell, the geologist, gave Darwin the time that he needed by saying, look at this Earth, look at these layers of sedimentary rock. They took a long time to form. Therefore, that gives Darwin his time for evolution. And another question it would be, if Noah's flood is true, would we expect the young Earth denying evolution the time it needed, right? So again, Darwin doubters, a young Earth would certainly deny Darwin. Of course, we found in the previous presentation that we need a lot more time than even if their timing on the Earth is true. We need a lot more time than that for evolution to take place. But whether we would expect whether the Earth is young or old, if Noah's flood was true and the Earth was young, or if just one or the other was, we'd expect the fossil record and the sedimentary rock to be a result of catastrophic events, right? Because isn't that what Noah's flood would be? A lot of catastrophic stuff going on and a lot of rapid processes. But we were told for 250 years the opposite. We were told in geology that the reigning principle was uniformitarianism. You weren't allowed to describe anything you see on the face of the Earth in topography and geology as having any kind of a mechanism that wasn't slow and long. Uniformitarianism. Here's our fellow Charles Lyell, who wrote a book called Principles of Geology. Charles Darwin read that book on his way from England down to South America on the Beagle, the ship the Beagle. It's the theory, again, it was the orthodoxy for 250 years until about the last 20 to 30 years. The theory that all geological phenomenon may be explained as the result of existing forces having operated uniformly from the origin of the Earth to the present time, as Owen was talking about. So what would that mean? If you saw a stream and there's granite in the bottom of the stream and you calculate that it takes 1,000 years to cut 1 inch into that granite with the stream that's going by there, and you see, well, we have about 30 feet of granite here we've cut through, then you would say, you'd multiply 30 by 12 by 1,000 years and you'd come up with a heck of a long time to cut that groove. So that's the way the Earth was supposed to be formed. Slow and weak forces. It turns out, of course, that uniformitarianism is generally not true. Big surprise. It's very akin to Darwin's small change mechanism not being true. Geologists now admit that catastrophe is everywhere. But again, they don't say the Earth is young. They say that just means there was 100 million years in between these events. The events were quick and powerful, but 100 million years went by. Now keep these two concepts in mind. We've been told for 250 years that geological mechanisms are very slow. And the Earth's surface was formed with weak forces. Weak forces. Go out in nature and look at some of the rugged terrain in the country and tell me that you think that was formed by weak forces. It's simply not true. We need massive forces, rapid processes to explain what we see. Massive forces and rapid processes. Now, I'm going to talk now about the fossil record and the evidence for catastrophic global flooding. I don't have very much on a young Earth, and I would like to talk about some of the problems that creationists have that still need to be explained from the creationist model. There's a young Earth model, which you would call the creationist model, and there's an old Earth model. But again, these are things that are still being discussed and as part of the 65 slides that I took out. We need at least an hour on each, but we're going to try to do the first two and a little bit of the third in about 45 minutes. So we're going to talk about the fossil record. Is it evidence for a worldwide flood or not? What are some of the secrets of the fossil record that aren't talked about very often? The fossil record is called the geologic column, right? It's It's supposedly about 540 million years back to the Cambrian layer here. And the Cambrian layer is where all the life is found. It's called this explosion of life that evolutionists have a very, very difficult time with. We have virtually no life in the Precambrian rock. We see some wormholes and now some jellyfish and some creatures like that, soft creatures. And all of a sudden, boom, we have almost all the phylas of life found immediately here. Then we have some other ancient layers here. There's the Devonian, the lungfish that I talked about was in the Devonian. We have the Carboniferous layers here, and that's where all the coal is found. Most of the coal is found in the Carboniferous. And then we have the dinosaur era, Triassic, Jurassic, Cretaceous. And then 65 million years of the modern era. Now, flood geologists, people that believe in a global flood, would say the flood ended there at the end of the dinosaur age. That's where most people believe it ended. There's always controversy about it. And that it started somewhere at the top of the Precambrian layer. So that's the fossil record. Of course, the creatures change as you go up the fossil record. This is a map of the Earth. I hope you can see this crack here. If we were to roll this up into a globe and have the crack on the globe, it would look like a baseball. There's basically a crack in the ocean that goes all the way around the Earth, looking like almost the seams of a baseball. And of course, the flood geologists say that this happened. When this happened, Noah's flood began. These continents were connected to these continents. This opened up, this spread apart, this subducted over here, and all the floor of the ocean, including the Precambrian rock, was dumped onto the surface of the continents. We know that's true because we know that the seafloor is young. There's no Precambrian rock. There's no rock all the way up to the time of the dinosaurs. There's none there. It emptied out onto the continent. And that's why fossils are only found on the continent. Basically, there's some fossils, of course, out on the shelf. And it's 95% marine fossils. That's why we find marine fossils on the continents, not because there was an ocean there that lasted for 1 million years or 100 million years. It's because that's where the ocean dumped its load. Here's a map of coal, where coal is found in the world. Again, we have no coal in the ocean, because remember, there isn't even any rock layers that have Carboniferous. They're younger than that, according to the sequence that we find in the fossil record. Look at this. Look at the coal just in the United States here. These seams are found all the way from the north to the south, massive layers. Look at this Siberian coal. Look at this up in Canada. You're talking a 400-year supply of coal, a massive amount of coal. And look at the way it kind of forms here, right? Not little peat bogs here and there, but in massive layers, right? Kind of indicating this massive amount of material kind of floating in and being buried there. So what do we see when we look at the fossil record? We see the Cambrian explosion of life, that I mentioned. We see lots of diversity at the beginning. Darwin tells us that we should have little diversity at the beginning and lots of diversity through time. The opposite is true. No transition or missing links. I mentioned that in my last talk, that they're just not there. We see stasis, no change. We see no tree of life. Living fossils, if they're alive today, they remain unchanged. Once they're found in the fossil record, they remain unchanged until they become extinct in the fossil record. They don't see any change. And that could last for 300 million years or more, 500 million years. Mass extinction, rapid fossilization. The only way you can get a fossil is if you rapidly bury it, exclude oxygen, and allow rock to form around it and minerals to flow through it and that sort of thing. Replace the bone with stone. You can't do it. No, there's very few fossils being formed today. River deltas don't have fossils. Things just rot away. Bacteria and other parasites and carnivorous, things just they get consumed by the earth very quickly. Dinosaur graveyards. So we see these massive graveyards of dinosaurs, but we don't see their food and their ecosystem with them, right? They were captured in these massive groups, transported and buried in big graveyards. How do they know? If it was something slow, how did the dinosaur know it was supposed to go there to die, right? They all died together. And again, as I said, 95% of those fossils are marine fossils. If evolution was true, we would expect to see this yellow line in the fossil record way, way, way back, a couple billion years ago, some sort of life, and eventually getting like this. In fact, we see the opposite. We see this Cambrian explosion, just a little bit of life before the Cambrian, boom, and then a loss of diversity with time. When we find something in the fossil record, like a spider 30 million years ago, or 58 million years ago, bat, or a salamander 160 million years ago, it hasn't changed. It appears suddenly. There's no transition to it. There she is, boom. It doesn't change if it's still alive today. We don't see this. This is Darwin's tree of life. We don't see that. We see the phyla of life, and we see some diversification of that same type of creature. And when the fossils are missing, they're missing selectively, right? Here's a branch of the tree. We have creatures down here and creatures up there. Their morphology might be similar. In other words, they might have 4 legs, right? And walk on 4 feet. So therefore we say they evolved, one evolved from the other, but we don't have anything in here. We don't have any transitional fossils at these nodes. The fossils are missing selectively. Why would the fossil record always be missing the fossils at the nodes? We see this. I hope you can see it. These mass dinosaur grave sites, right, where most of the bones are jumbled up and broken up, tumbling in and being deposited there in a big, massive graveyard with no food, no ecosystem there that would have fed those dinosaurs. Why would they be separated from where they got their food and lived? You see this. This is a fish. It's having its lunch right there. These are common. This is not just, oh, look at this particular one. These are common, where this fish was captured while he was eating his lunch. All of a sudden, things were fine, and boom, he was dead, captured in the middle of life. We see fish having a baby, pushing a baby out of the fish. We see dinosaurs who are actually fighting with each other and captured. We see creatures that just ate a bird or something like that, and we see the bird in the stomach in the fossil record. This instantaneous capture. We see all kinds of soft creatures that should rot very quickly, and yet we find now in the fossil record incredible detail of what was there. Slow processes, remember, we're told slow processes don't fossilize anything. Things just rot away. Very few fossils being formed today. Again, it needs to be catastrophic for something to be captured and turned to stone today. The trilobites. What the heck is a trilobite? Well, I have one of these guys in my little collection at home. The maximum size is only 2 inches long. It's called a kinji. Trillions of these things have been found in the fossil record. Always on land, of course. Yet they were bottom dwellers in the bottom of the sea, a lot of them. They supposedly existed for 325 million years old, and they never changed. Once they found a particular type of trilobite, it never changed. In fact, they found so far 17,000 different species of trilobites. And they were complex creatures. They had eyes that could see under the water, compound eyes that could see without the parallax that we see. So they could judge distances, right? This creature at the very bottom of the fossil record. Here's my little kinji over here. You see it was born down here in the Cambrian layer, and for 90 million years it never changed, and then it went extinct. It couldn't find it anymore. Again, we're using evolutionary dating times, standard dating times. When I say these years, I'm not saying that I believe that long. And all these other families, these are families of trilobites, they all tend to come down to the same spot here, don't they? Question mark, all basically at the same time. Here's families. These are numbers of families, like 40 or 50 families of trilobites, and this is where they're found. Now, just take a look at that. This is upside down. Remember, we're supposed to have very little diversity at the beginning, which turns into all this different type of trilobite life. So it's upside down. And the last guys living in the fossil record were shallow dwellers. And these guys were extremely robust. They could live on very little oxygen, right? Why'd they die? Well, their whole habitat was emptied out of the ocean and dumped on the surface of the earth. They lost their habitat. That's why they died. This guy by the name of Carl Werner is a medical doctor. He was challenged as a young professional about evolution. He, of course, believed in evolution, and he started to investigate, and he decided to become an expert in fossils, and he looked at where the dinosaurs lived, Mesozoic era, where the dinosaurs, Jurassic, Triassic, Cretaceous, and said, let's look there. And he traveled all around the world to all kinds of dinosaur dig sites and museums. So let's see what we have there. He found all forms of life there that were not supposed to be there, like flowering plants. They're not supposed to live at the time of the dinosaur. Frogs, modern fish, birds, mammals, all these things we were told are not supposed to be alive at the time of the dinosaurs. Here's a horseshoe crab. Where I live in, my friend from Upper Darby over here, where I live, we see these every year on the shore down at Ocean City, down the New Jersey beaches. And they're found in the fossil record 540 million years ago, unchanged. It's the exact same creature, 540 million years, no change. Here's the Maine lobster. It's not that old, but it's very, very old as well. It hasn't changed. And when scientists find these creatures, like this shrimp here, I don't think you can see it too well, this shrimp here is exactly the same thing as found in the fossil record. But when they find it in the fossil record, they call it something different. They call it a different genus and species name because they don't believe it could have been the same creature, because it should have changed. Evolution should have changed it. It must be something different. And in his book and in his videos and all, he goes through fossil after fossil after fossil like this with these kinds of stories. This is a scientist. I'm sure he's not a creationist or anything like that. But he says, yeah, we find plenty of mammals buried with the dinosaurs. 280 mammal groups so far, nearly 100 complete mammal skeletons. And not only that, all the 7 major plant divisions that are growing today in our world are found with the dinosaurs. We've been told that that's not the case. Now, what do we see then with this? What's our flood view of geologic column, right? Again, as a flood geologist or creationist, we would expect to find initial complexity at first appearance. That's what we find. We'd expect rapid burial on a large scale from a massive flood, a global flood, and that's what we find. We'd expect mass extinction, that's what we find. Decline in variety, not gaining in variety, because we made a lot of creatures extinct. So we expect them to, we expect it decreased, and we do. Stasis, once we find it, it never changes. If it goes all the way to the present day and still living today, it hasn't changed. No missing links have been found. This is what we find. Evidence for a worldwide flood catastrophe in the fossil record. Now I want to switch over to geology in general, and we're going to find more evidence for a flood, and I'm going to talk about 3 examples of real-life examples here. One is, and these are situations that we know what happened there, like Mount St. Helens volcano in 1980. We've been observing it for the last 30 years. The Columbia Gorge, we didn't know what happened there for 100 years. The guy who came up with the idea that it was a flood event was ridiculed for 50 years and then finally given a great award when he was about 90 years old in the 1990s for his bravery. And the Grand Canyon is very controversial, but now the consensus is that there's catastrophic events that formed it, at least. And of course, now I want to point out that these are all post-flood events I'm going to talk about. These are things that happened after Noah's flood, but they're evidence of powerful catastrophic mechanisms and rapid processes. Remember, we were told weak forces and slow processes, but what we observe in reality is fast processes and massive forces. Here's Mount St. Helens, May 18th, 1980. The top blew off of this thing. There's a caldera there. It's a mile wide. Can't see this very well from where you're sitting, but there's a wasteland that was created there. Top of the mountain blew off. At this point, about 3,000 feet. At the back here would be 1,200 feet of mountain blown off. Boom. And we're going to see rapid processes, not millions of years. I'm sorry you can't see this very well. But this is a lake called Spirit Lake. The volcano's back there. And what you're seeing here is trees. 210 square miles of trees were ripped away from their root structures and laid here. 4 million trees were knocked down by this volcano. And this volcano is a weak volcano. Some of the slides I took out show how weak this volcano is compared to volcanoes of the past. 4 million trees, bang, they're gone. Here's the volcano. Over here, so it blew out towards the north, and over here, 600 feet of sedimentary rock was laid down in a very short period of time. Here's our Spirit Lake. The lake surface rose 250 feet up the mountainsides, and 300 feet of sediment. 300 feet of sediment was pushed into the lake, and when it did, it pushed an 860-foot wave up the slope, and when it came down with the force and all the speed and the velocity, it totally scoured the scope. No trees left. There was nothing left but rock. So powerful forces. This is Spirit Lake. There's the volcano. This is the log mat that was floating in the lake. And this is, again, a close-up. Remember, each one of these little toothpicks here is 40, 50, 60, 70, 80 feet long. 2 million logs floating in this lake. And the lake started to fill up because there was no natural outlet anymore, and they got nervous and they drained the lake. When they did, they found 15,000 of these logs were sticking upwards at the bottom. And we see these, what are called polystrate fossils, everywhere in the fossil record. See, this is a tree, and this is a tree that turned to stone. And where we find them, we typically find several million years of geologic time where this polystrate fossil penetrates, right? We know, of course, that if that was planted in that first layer and a million years went by, it'll be long gone, but several million years, we're told, went by, and these layers build up. The polystrate fossils is still there, and it's a piece of rock, petrified wood. So what happens here is a lot of logs float, a lot of them come down here, and they become a peat layer, and then if there's enough sedimentary rock and enough heat, volcanic heat maybe, or earth heat, they become coal. So we see kind of, at least the beginning of peat formation. We see how these polystrate fossils are formed as well. And there's a place in Yellowstone Park called Specimen Ridge where they have 27 layers of this stuff, and they've been telling people on the signs there that this took hundreds of thousands of years for one forest to grow, die, another one grow, die. But in the meantime, all the logs there, all these vertical pieces, are turned to stone. Why would that be? If it was that, so they've now looked at it and found out that indeed a lot of them died at the same time. And they fall down at different rates too, depending on how much of how thick the bottom is, whether they have any root structure. So, and also what species. Certain species of trees get waterlogged more quickly. So that's what you see happening. So we see rapid processes, the beginnings of rapid processes. Remember I told you there was 600 feet of rock? This is that layer, but this is only 60 feet of it, right? This is only after about 5 years. And this is a pyroclastic layer. What does that mean? Well, when the volcano is very active, it's pushing stuff down the slope with hot gases. They call that pyroclastic flow. So the gas is escaping, and when that happens, you end up with these laminated layers, right? Remember, science tells us that every lamination is a year, a season, maybe a couple years, or bottom of a lake, that kind of thing. So somebody would look at that and say, well, that's at least 1,000 years. It happened in a couple of hours, right? Look at the cliff. The person's sitting right there. There's a woman right there. There's a cliff there that's 60 feet high, and within less than 5 years, it's turned to rock, right? So again, fast processes. We're told that rock takes a long, long time to form. Fast processes are occurring. This is there's a little waterfall here. This is about a 100-foot drop. This was supposedly ancient solid rock lava. So it was a 100-foot canyon formed very, very quickly here in a couple of days. So a quick summary of Mount St. Helens. Rapid sedimentation, layering, and particle segregation happened in one layer, not in multiple layers. Rapid canyon formation, rapid rock turning to rock in 5 years. Rapid model for petrified wood or coal formation or peat. And obviously all formed by massive forces, massive energy, not small forces. I want to talk about the Columbia River Gorge up in Washington State. called the Scablands. Here's Washington State, here's Montana, here's Idaho. So this, you're talking hundreds of miles. You see this gray area here? All that is all canyon, gouged out. Here's, if you ever heard of Grand Coulee Dam in Grand Coulee, Grand Coulee is a big valley that was cut through the rock that was there. And it's 50 miles long and 1,000 feet deep, just this piece right here. Palouse River flows into the Snake River, flows into the Columbia River. I'll talk about that in a second. What happened? Well, we had the ice age that plugged off this area here, and it all filled with water, a massive amount of water going all the way across Idaho and into Montana. And of course, it melted and it let loose and it cut this in one event, basically. Here's a beautiful picture of the Columbia Gorge, all sedimentary rock, cut through. A lot of it's lava, big lava basalt deposit there. This is called Dry Falls, Grand Coulee. So this is a 350-foot cliff. In the bottom of that, there's a 300-foot gouge. All this was gouged out by the water that was escaping from that Lake Missoula. 650 feet. Of course, it's dry now because the water's gone. It turns out that we have a lot of these mega floods, either after the flood or during the removal of the water from the continents at the end of the flood. I just talked about Grand Coulee. I'm going to talk about Grand Canyon. Down here's the Santa Cruz River. That was specimen number one. That was, what do they say, is an evidentiary trial, right? Evidence for uniformitarianism. Again, our friend Darwin came on the boat on the Beagle, reading Lyell's book. He came down here, saw the Santa Cruz River, and he said, ha, here's evidence. This is exactly what Lyell's talking about. Now it's turned out that it's one of these mega floods. They know it formed, that all the topography that he was looking at formed very, very quickly from the release of a mega flood. White Cliffs of Dover, what's going on here? Here's the White Cliffs, the beautiful chalk cliffs of Dover. Here's England, here's France, here's the White Cliffs are in here. Again, glacial meltwater cut the English Channel. And we know that by looking at the gouging out here below there. Right? Massive forces, not gradual forces. So a quick summary of the Columbia Gorge. Again, catastrophic forces forming the geology that we see. Rapid canyon formation. One of the great many mega floods from water left behind by Noah's flood or post-flood catastrophes. Look at the world. The ocean was warm, right? These minerals were coming up from the ocean. The earth split open, lots of hot water, and therefore it took a long time for the ocean to cool down again, hundreds of years, and huge hurricanes, hypercanes they call it, all kinds of other floods and things that happened afterwards, enough to form the ice age and all that water that was taken out of the ocean and various surging and things like that going on. Brings us to the Grand Canyon and how it formed, right? Who's been to the Grand Canyon? I know this guy has. Yeah, so when the first time you walk up to that ledge and look at it, you can't believe it. No video, DVD, photographs, nothing prepares you for what you see when you walk up there. And they try to tell us that little Grand Canyon down in there, that little Colorado River cut that thing. And nobody believes them, but they continue to tell us that. It starts up here at Lee's Ferry. You can see these cliffs here. This whole area here was gouged out. And for some reason, it makes a right-hand turn and goes west for 277 miles. It comes out here at the Grand Wash Cliffs. This lake here was formed by the Hoover Dam, and here's Las Vegas. It's up here at the corner of Arizona, just below Utah, just next to Nevada. When we look at the cross-section through the canyon, we see these tilted layers. And we see that for some reason that it was planed off and we built like a layer cake on top of it, horizontal layers. So the Precambrian rock existed, it got tilted, some massive hydraulic force came through and planed it flat. Right? These are all these layers are all different hardnesses. So if one got eroded, the other one would still be sticking up. They wouldn't all be flat unless there was this massive force that planed it flat. We see all these different interesting layers. Down the bottom here, we see igneous rock and metamorphic rock. As we go north into Utah now, we see something called the Grand Staircase. We see the Grand Canyon over here. We see the Precambrian rock. We see that this area here has been uplifted 1.5 miles from where it used to be. And over here, if we follow the layers down, over here we see there's at least 1,000 feet of material that has been removed from the Grand Canyon area. Tremendous erosion taking place. So here's one of the most coherent theories of how it formed. Theoretically, there were two lakes. Of course, the topography out there allows the formation of two massive lakes up through Utah into Colorado, another one over here all the way to the border of New Mexico. One they call Hoppy Lake, another one they call Grand Lake. If you've ever been to Monument Valley, people know what Monument Valley is? See these buttes in Jeep commercials or in John Wayne movies. There's tremendous topography, nothing there but these buttes sticking up, right? That's right in the middle of the lake there. Over here is where the petrified forest is, where the logs were buried and turned to stone. You remember our log mat floating on Lake Spirit, getting buried in the sediment below? That's exactly what happened here. In petrified wood, the beautiful red petrified wood. Father has a piece of it. Is that from the petrified forest on your when you walk into the church? Because it looks like, because it's red, because most petrified wood is brown and gray and kind of uninteresting. But from the petrified forest, there's so much iron in the water that it's all red and beautiful. So we had two excavation projects here. First, we had to take a 10,000 square miles, 1,000-foot thick layer off of the Colorado Plateau. So we planed that off, and then we had to cut the Grand Canyon, another 800 to 900 cubic miles of material. So we're talking about 2,900 cubic miles of material had to be removed here. Do you think this was some slow process did this? What's the likelihood of that? Here's the theory. So here's Grand Lake. Of course, it breaches. It starts to trickle through here. It eventually planes off. More come through, and this tremendous lake planes off the Colorado Plateau. And while it's doing that, it undermines the Hoppy Lake. And sure enough, they start to cut the Grand Canyon. This is the Grand Canyon before all the other side channels were added to it. Big controversy over this Kaibab Plateau here. Did it uplift before the flood or after the flood? Because all the geology here goes north to south. This material, this water should have just kept flowing south. Why does it make a right-hand turn and cut that, especially through an upwarp, if the upwarp was already there? So here's, if you go out there to the west, not far from here, you see all these incredible national parks. Marble Canyon, Bryson, Zion, Monument Valley, Petrified Forest, right? And they're all within those lakes, all cut by hydraulic forces. They're all this beauty that we see out there is from the same events or series of events. Now, we've talked about the fact that we're missing these layers on the top of the Grand Canyon. It's something like 250 million years are missing. But down here in the middle of the Grand Canyon, we're missing 150 million years. We've got these layers. We've got the Cambrian, we've got Precambrian, but we don't have those layers. Another 150 years are missing. So were they really 150 million years there is one of the questions. Here's these beige layers are layers they find at various places. The top of the Grand Canyon is in here someplace. The top of Monument Valley, the top of those mesas and buttes there are right in here. So it's above the top of the Grand Canyon. And all this time is missing, all these cross-hatched areas. So one question we could ask is, what happened there? Did really that amount of time pass? In fact, the evidence would indicate that it didn't. We see these unconformities. In fact, I forgot to show you this great unconformity. Remember the tilted layers in the layer cake on top of it? That's called the great unconformity, where all of a sudden we've got layers going one way of the plane, and then we've got this layer cake built up. And we see these non-conformities between all the layers in the Grand Canyon. Here's a different type of rock, and you see this like knife edge here. There's no evidence of 150 million years or grooves and erosion and changes in topography that would have happened. It's one layer bang, then the next layer bang, the next layer bang. I hope you can see this, but this is the Cambrian layers at the Grand Canyon, like a layer cake on top of the tilted Precambrian. Again, that's called the great unconformity. It doesn't conform with uniformitarian thinking. How'd that happen? Where did it come from? At the top of the Grand Canyon, we see something called the Coconino sandstone. And this is found over many, many, many hundreds of square miles. If you could see this, it's called cross bedding. You see these vertical, horizontal, and not so much horizontal, slanted layers in here. And we know that when we see that in sandstone, it's either formed by a desert or an ocean, right? Because what's happened, the water's flowing over the top, it's creating these mounds, either by wind or water, and it's flowing over and it's creating this cross bedding here. So we see a bed going there, and we see cross bedding, it's called. We know how it's formed. And for years, they told us the Grand Canyon was formed. First, there was an ocean there. Then the Coconino sandstone was a desert, and then there was an ocean on top of that. And therefore, that's a couple 100 million years, or a couple 100,000 years, or whatever it might be. And that's how it was formed. That's how they justify giving you this age. Turns out they were all formed underwater. How do they know that? Well, from looking at the fossils, they find that these little creatures trying to get up the slope as the water's coming in. They find their footprints, and then buried real quick so it becomes a fossil. If it was sand, it would just be a puncture mark. There wouldn't be any little feet and claw marks in there. So they're now, because of this and other evidence, they now agree that the Coconino sandstone was formed underwater. If you could see this is a beautiful picture of red cross bedding here, another close-up of the cross bedding. I now want to talk about the red wall limestone. This is a layer just above the Cambrian. It's a 50-foot layer of limestone in there, but the layer that holds these guys in that layer is only about 7 foot. So about 7 foot of the 50-foot layer has these nautiloids, right? They look like a squid, modern-day squid, but they had a cone on them. And they're found in this layer. This is about 7 foot wide. This is the guy who found them, a geologist by the name of Steve Austin. He spent 9 summers, at least a couple weeks in each summer, mapping the Grand Canyon after he found these things originally. And this is over near Las Vegas, right? Again, we see this red wall limestone. It turns out they found this layer 200 miles long, 5,700 square miles, 100 cubic miles of limestone. And they find these guys. How did these guys know they're supposed to go into that limestone and die, right? It had to be something catastrophic. Here's a fossil stone cone here, turned to stone, of course. Now, after they mapped this, they found out that the extent of this, the density of these things, there's at least 4 billion of them in this layer. Up to 10 billion of them. 4 to 10 billion of these guys were captured instantaneously and killed. And how do they know that? Well, because a lot of them are found with the tail sticking up. And the rest of them are found in this directional flow, right? So that they see, okay, they're all kind of laying in that direction. As they map them, they find the water was coming from east to west. And this mud layer underwater captured these guys and just buried them instantaneously. Like evidence of catastrophic forces, catastrophic events, and rapid processes. Here's another picture of the cone. See the cone here in the picture turned to stone. And this is Steve Austin's map. I showed you this before, but you see all these little squares and rectangles, triangles, and stars? These are all places. The first finds were up here in Marble Canyon. And then they found them all the way down the Grand Canyon, all the way through Las Vegas, and all the way into California. 4 billion of them at least. So we see catastrophe had to cut the canyon. We may not have the mechanism exactly right, but even the most mainstream books on the canyon are now talking about catastrophe. Massive flood event. Sediments, of course, were laid down during the flood event. Rapid deposition underwater. We know it's underwater. Unconformities. No time in between these layers. We're missing hundreds of millions of years, and we have this rapid nautiloid kill. Now, the above 3 events were after Noah's flood. But the sediments, of course, that these things cut through came from Noah's flood. And what other kinds of evidence might we have? I mentioned the White Cliffs of Dover. These White Cliffs are, in some cases, 1,200 feet thick. And what is it? It's chalk. What's chalk made out of? Dead sea creatures called coccoliths. This is 1,200 feet of dead sea creatures. How do they know they're supposed to come here to die? Why are they just here? In fact, they're not here. This cliff, this layer is found all the way across into France, Germany, Poland, all the way to the Middle East. This is a close-up of the chalk. I don't know if you can see it very well. Just absolute purity. When it's deposited today, we don't see this kind of purity. This happened to happen fast. Now just think of the ocean, how mineral rich it was after the flood. The earth broke open, all this material's flowing out. We got heat, and we've got minerals. We had a very rich ocean, and these blooms of these creatures are happening on a massive scale and dying. In fact, we see these blooms from satellite today. These are blooms right off the coast of England, coccoliths. But we don't see, here's the White Cliffs again, we don't see, we calculate that if at today's rates it would take 30 million years to create these deposits, right? But we know it didn't take 30 million years because it's too pure for that. Way too pure. We'd have all kinds of other stuff mixed in. So massive things. Just think of the forces, the food, the chemistry of the ocean at that time. You need a massive amount of iron and calcium and sulfur dioxide to form these coccoliths. This is one of my favorites. I worked for a chemical company that owned Morton Salt. Morton Salt produced a lot of the rock salt that we have around the country, and they have salt mines up along the Great Lakes and down in the Gulf of Mexico. This is the Gulf of Mexico. This is Houston, Texas. We got blue dots and green dots, and what they are these salt domes. I was down in one of these salt domes. The only way we can get rock salt is because these plumes, right, that come up close to the earth, and we can drill a shaft maybe 1,000 foot down and drill horizontal mines in there and get the rock salt out. These are the plumes. The layer of salt is absolutely pure. If you've ever been into one of these salt mines and in the middle of one of these plumes, it's absolutely pure salt. There's no evidence of a seabed with all kinds of dead creatures and dead plants and dead stuff. It's just pure salt. It bubbles up from 20,000 feet below the surface, which is way too far down to mine. It covers 100,000 square miles, and it's a mile thick in some places. Pure salt. Just think of the earth that's broken open and oozing out sodium and chlorine at levels that can spontaneously react with each other and form these salt layers. Of course, the specific gravity is much lighter than the sedimentary rock layers. So what happens? It's being pushed down, it finds a weak point, and of course, with the lower specific gravity, it comes to the surface. It's still soft. Now it's hard. It was soft then, and so were the layers, so it pushed the layers out of the way. And it turns out there's something very strange going on with oil. Whenever you're down there along the Gulf and you go up on anything high, you look out over the salt dome where you just came out of the SAP, you see drill rigs, oil derricks everywhere, because oil tends to agglomerate right there. Of course, the salt plume, especially if it's got like a mushroom shape, it's totally impermeable. Oil can't get through it, so oil that's migrating is going to get caught there. But there's some other thoughts about the fact that salt with other kinds of rock might actually form organic deposits like this. So far, we've seen fast processes. We're supposed to take millions of years, right? Canyon sedimentary rock, laminated layers, rapid deposition, little time between layers, unconformities, fossils that go through millions of years of layers, massive erosion from flooding, petrified forests, origin of salt is not what they've been telling us in terms of these seas that are supposed to, evaporate. What happens when the water comes back in? It just dilutes the salt again. It just dissolves the salt. It doesn't make any sense. But you have to have a uniformitarian explanation for everything you see in geology. And that's why they told us about the seas evaporating. It doesn't begin to explain what we see there. Sea chemistry difference, giving us these massive blooms. Diatomaceous earth we use for our swimming pools, right? That's another type of sea creature. Again, we find it in these massive deposits. I took it out of the presentation. Let's conclude with some other general evidence for geologic catastrophe. We want to talk about sediments over whole continents and horizontal segregation, how that happens. So this is the Tapeats sandstone at the very bottom of the Grand Canyon in the Cambrian layers at the bottom of the Grand Canyon. And it's been tracked all the way across the United States, up into Canada, and actually through Alaska into Greenland. It's one of 6 megasequences that have been tracked that way. Massive continent-wide deposits. Not a local flood, a continent-wide flood. You can't see this very well, but here's a person standing here, and here's a circle and another circle, and these boulders are 15 to 35 feet in diameter, and they're in this sandstone layer. So they were the velocity of the water and the volume of the water had to be so massive that it could carry these kind of huge boulders along and deposit them in the middle of the layer. This is a friend of Hugh Owen. This guy, Dr. Guy Berthoud, he's a French scientist. He's getting very old and doesn't travel, I don't think, anymore. But he's done a lot of work on how multiple layers could form at the same time underwater, right? In this case, he's just got a beaker, and he's got different particle size materials in there, and just shaking the beaker, he gets these laminations. Again, we saw those laminations from hot gases escaping and clarifying, what's called clarifying the various types of various sizes of particles in the material, and making it look laminated, right? He also did work in the lab. Here's a flume, and he did work in the lab, and he found that horizontal water flowing with various particle sizes will deposit according to their particle size. So you could have a sandstone layer and a silt layer being formed at the same time. And that's indeed what we see frequently in nature. You know, something like 70% of sedimentary rock is shale, and the other 20% sandstone, right? The rest of it's limestone and variations on a theme. Again, this doesn't look like you can see this very well. This is a national park in Derbyshire, UK, in England. That's a 300-foot cliff there. You can't see it, I'm sure. But they now have determined that it's laid down underwater. These turbidity currents, they're called, is laid down underwater. There's 100 layers here in this 300-foot cliff, and they now think that it was all laid down basically at the same time, or in, you know, various surges, multiple layers at the same time. Turbidity currents. So that is my geological evidence. I do want to finish with a couple of other thoughts here. These next things could be either evidence for a young Earth, perhaps, or a recent flood. If we were to list some of the best arguments for a young Earth, it would take about 3 slides like this. Again, I took a lot of that out of my presentation, but we've already talked about 2 of them. The first 2 are devolution of man from mutations, right? It looks like that we're devolving, and that would indicate that life that is young on the Earth. That doesn't mean, of course, the Earth wasn't sitting here for 4 billion years, but it's evidence of a young, young genome anyway. How about flood geology? We've talked about that. Catastrophic events, of course, don't need long ages, so that's kind of evidence for a young Earth, but doesn't prove the Earth is young. I want to talk about heliums retained in zircons and dinosaur tissue. You mentioned in the question and answer last night about carbon-14 being found everywhere, all the fossils of the fossil record, every place it's been found, there's something that could be carbon dated, is carbon dated, it's found to be young, not hundreds of millions of years old. We find carbon-14 in diamonds and coal as well. Remember, coal is supposed to be 250 minimum years old, and diamond is supposed to be billions of years old, believe it or not. It's supposed to have been formed deep in the bowels of the Earth, 40,000 miles down, and gradually moved to the top over billions of years. What's a half-life? So here's uranium decaying to lead. All right, a half-life is when half of the material disappears. It decays to something different. So here we have a parent, and in one half-life we have half of it left. After 4 half-lives, we only have a 16th of it left. For carbon, that half-life is only 5,700 years, and therefore carbon should be gone after 100,000 years, or we shouldn't be able to detect it, right? And that's why you was talking about it last night. Uranium, however, has more like 1 billion years over there's 8 steps. It's got a very long half-life, and therefore it can be used to measure the age of the Earth. And these are little zircon grains that you find in granite. If you take a piece of granite, look at it carefully, you'll see these little sparkly things in there called zircon grains. And they're made out of zirconium, and the uranium atom is basically the same size, so you find a lot of uranium trapped in the matrix of these old zircons. Now, here's the uranium, and it takes 8 steps to become lead. And if you look at it and make some assumptions, you can say, okay, we got a lot of lead in there, therefore this particular grain is 1.5 billion years old. But every time it goes through one of these 8 steps, it spits out a helium atom, two protons, two neutrons, and the electrons that go with it, right? So now we should have eight helium atoms in there. But it's a slippery molecule, as we know. It comes out of a balloon very quickly. How are balloons doing over there? But by tomorrow morning, right, they'll be on the floor, right? But anyway, helium, we know how fast it diffuses through rock. It should be out of there by now. But when they look at the amount of helium in there compared to the other two elements, they find it should have only happened 6,000 years ago. So people would say this means that there was an acceleration event during the flood, right? And creationists are looking for that mechanism, which they don't have. People have tried heat and pressure and other things for a long time, bombardment with radiation and X-rays. It doesn't seem to advance the mechanism of decay, but something happened during the flood is the theory that created old radiometric dating, because this looks like, and there's other evidence with halos and things like that that's too complicated to get into this presentation. This slide says I'm saving the best for last, and I think I am. And here you see a T-Rex and a Titanosaurus. And they have found now dinosaur tissue intact in bones of these creatures that's supposed to be at least 65 million years old, tissue. Now remember, the first part of the miracle is they found a bone of dinosaurs, because remember, fossils are something that was alive but would have rotted away if it hadn't been replaced by minerals that turned it to stone. So if you have a dinosaur bone, that's pretty miraculous to begin with, because that's supposed to be 65 million. How did it survive? Now this lady here, Mary Schweitzer from North Carolina State University, you see her sitting here in front of a T-Rex skull. Back in 1990, she was looking at a dinosaur bone, a T-Rex bone from Montana, and she created these slides here. She says, I think I see tissue in there. Blood vessels, and not only that, blood cells. Blood cells decay very, very rapidly. They told her she was crazy. We know they told her that nothing, even the finest preservation techniques, would be alive, buried in rock, buried in stone. It decays, it's natural, it just decays. It'd be gone after 10,000 years. And they said, you're just a young scientist, you don't know what you're doing, you've contaminated the samples, go away, don't bother us. About 10 years later, in 2005, she published another paper and she proved that she was right. She took all their objections, she took all the care needed to make sure she avoided contamination. 2009, another paper, a further defense. Now nobody disagrees with her. In fact, there's been, just since 2009, there's now been 42 papers published. 26 of them are shown on this graph. There are things that are supposed to be hundreds of millions of years old. They're finding all kinds of shells or ink or whatever, right? Now let's look at this chart. We got millions of years over here, 0 to 400 million years. And across here we have the various creatures they found, frogs, salamanders. Salamanders supposed to be 25 million years old. Here's a primate of some sort, almost 50 million years old. Here's a mammal, 100 million years old, right? Here's our dinosaurs, up to over 200 million years old. This creature over here, I don't know if you can see it there. It's got a shell like a lobster, kind of. It's made out of chitin, which is the same material that our fingernails have, and it decays very rapidly. And yet they found the shell. It's called a ripterid. This creature's called an ripterid. 400 million years old, they found the shell of this creature intact. And now recently they found DNA. Now we know, you see, this is the half-life for DNA, 521 years. That doesn't mean if there's a piece of roadkill on the street that's going to lay there for 521 years. That means that you've buried it, you've protected it. And even then, DNA falls apart very quickly. 521 years, half of it's gone. So it doesn't even hardly move past 0 on the chart here, and they're finding it in a dinosaur 65 million years old. And in these insects and amber and what have you that are 40 million years old, something like that, right? How could that be? They're totally baffled by it. And this is one of their own, an evolutionary paleontologist, Mary Schweitzer. She's one of them. She's an old Earth And all they've come up with so far is, well, this proves we were wrong about that 10,000 years, doesn't it? And yet every experiment, everything they know about it, they know how fast it breaks down. It's been measured. So is Noah's flood real and global? And is the earth old or young? Right? Two final questions. And of course, in reality, if we're really honest with ourselves, the data we have doesn't prove or disprove old or young Earth. Why? Because people say, well, that's just an anomaly. We're going to explain those dinosaur problems pretty soon. You know, we haven't yet, but we're going to get to it. We're going to explain that carbon-14, there's probably something we don't know about carbon-14 that's going to prove that that carbon-14 testing that UON's been doing is not valid. So the battle will go on for quite a long time. We're not at the stage with biology where we know Darwin's mechanism doesn't work. And even if you agree now, catastrophe has created most of what we see on the earth, it only says that uniformitarianism was a bad theory, doesn't it? It doesn't really prove an old earth, right? And fossils, you can believe what you want about the fossils. We know that they fit the young earth, or at least the Noah's flood model, much better than they do the old earth. But they're going to look at those things and say, well, look, we still have these layers, and there's a lot of creatures in there that are extinct, and I believe that these other things that are kind of proof that there is some transition there and all that sort of stuff. It's just the arguments go on, right? So reason alone, or evidence alone, or the data that we have today can't prove beyond doubt that Noah's flood, right? Or the age of the earth, right? Let's be honest with ourselves. We don't have it nailed shut. But everything that I've explained to you today is probably the first time you ever heard it, right? The fact that this information is out there and we're only being told that everything is old and ancient and we have the proof of it and the case is closed. And there was no Noah's flood. But it seems like it has to be true, and Scripture tells us it's true, Noah's flood. And powerful catastrophe explains most of what we see, and processes are rapid now. We see that. It has to be. And they're continent-wide and global, but the full picture is murky. And we always have to leave room for God's power. Did God create life? Did God create the universe? Did God predict ahead of time Noah's flood and prepare the earth for that? What happened between Good Friday and Easter? Right? A God of the gaps, right? God did something there very specially, and he rose from the dead. Creation, God called forth these things from nothing. God created the universe, he created life from nothing. And he has revealed himself to us, otherwise we wouldn't know. So I believe there's powerful evidence. I've always believed in Noah's flood. It was taught to me as a young boy, and I never believed it, I never really doubted it. And from the fossil record and catastrophe and the reliability of Scripture, we believe that it is possible, that we have the evidence for it. We have the evidence to believe that Scripture is reliable and telling us the truth. And when it describes it as historical, it most likely is. And that's kind of the state of the science at this point in history. And like anything else, there's advances every year. But remember, there's not too many people working on this side of the coin, right? So this development is much slower than the biology that I was explaining to you earlier in my previous presentation. And of course, that's why we're interested in these scientific controversies. They're extremely fascinating. And what we find, if we look, is that they do very much improve our faith and give us a reason to go out and defend our faith in the public square. So thank you very much. Thanks for your attention.